For our first lecture video, we're going to revisit some of the notes we already took in class before the schools were closed. And this was from the chemical bonds note packet that we received in class. So you probably have most of these notes already written, but we're going to take a look at it just to review what we were doing before all of the closures. So chemical formulas show the elements and how many atoms of each element there are. We did the examples of C12H22O11, and we were able to tell you that there were 12 carbons, 22 hydrogens, 11 oxygens. For magnesium hydroxide, 1 Mg, 2 O's, and 2 H's, because remember the 2 will distribute to both the O and the H. For the H2SO4, 2 H's, 1 S, and 4 O's. A little bit more difficult of an example with distributing would be the Ca3PO4 2 that we done in class, where you would have 3 Cas, the 2 would distribute to the P, and you would have 2 P's, and then you would multiply the 2 by the 4 oxygens to give you 8 oxygens total. So those were some of the things that we talked about in class for interpreting chemical formulas. We got into the basics for bonding. We reviewed the terms electron dot diagrams, that they show electrons in the outermost energy level, or the valence electrons using chemical symbols and dots. Where valence electrons are the outer energy electrons, and they are responsible for helping atoms bond with each other. So for our specific number of valence electrons that we'll end up referring back to several times in this unit, for the periodic table, looking at the groups on the periodic table, group 1 on the periodic table has 1 valence electron, group 2 has 2, group 13 has 3, 14 has 4, 15 has 5, 16 has 6, 17 has 7, and 18 has 8. And we're going to be using those valence electrons to model bonding for some different types of bonds. So chemical bonds are forces that hold atoms together in a compound. And we're going to learn how to sketch models for these by either showing where electrons are shared or transferred to gain a stable or full energy level. Hydrogen needs 2 electrons to be stable. Most other atoms need 8 electrons to be stable. We learned a new term for this unit, and that was ion. An ion is a charged atom that has gained or lost electron, where a cation is a positive ion that has lost electron. An anion is a negative ion that has gained electrons. It has a negative charge. So we had done the examples in class of trying to figure out how many protons and electrons are in an ion. It's helpful to remember that the atomic number will always equal your number of protons. So for our first example with the barium, barium has an atomic number of 56. So for our protons, we would put in 56. Since it has a positive charge, it will lose 2 electrons. Where if you have 54 negatives and 56 positives, it will give you a charge of +2. Chlorine has an atomic number of 17, so it will have 17 protons. It has a -1 charge, which means that it has gained electrons. So if you have 18 negatives and 17 positives, you'll have a net charge of -1. We also did the aluminum example, where aluminum has an atomic number of 13. Okay, it has a 3+ charge, so that means that it has lost negatives for a total of 10 electrons. Nitrogen has an atomic number of 7. okay, which would mean that it has gained electrons for a total of 10 electrons. So they have asked the question down here, which of the above are cations and which are anions? Barium would be a cation. Aluminum is a cation because they have a positive charge. Which of the above are anions? The chlorine 1-. The N3- would be anions because they have a negative charge. Now, I'd like you to scroll through your videos. Well, after you do the video, there are some questions for you to answer in the PowerPoint or the Google Slides with that ask you about interpreting chemical formulas and also determining the number of protons, whether or not an ion is a cation or anion, whether it will gain or lose electrons, and its total number of electrons. And you can complete that for practice before you start the next lecture video.